In this tutorial, you will learn how to conduct a one-sample t-test by hand. Our research question asks if college students on average get the same amount of sleep as adults, who get an average of 7.25 hours of sleep. We took a sample of 123 college students and found their average to be 6.8 hours of sleep, with a standard deviation of 1.25 hours. So we asked, are college students getting a different amount of sleep compared to the average adult? In order to start this, we must start by writing our null and alternate hypothesis. Our alternate hypothesis is the one that matches our research question. In this case, the alternate hypothesis is that our college average is different from 7.25 hours of sleep. So we want to know, is the population average for college students different from 7.25 hours? Our null hypothesis is that they're getting the same amount of sleep, so mu equals 7.25. Our t-statistic calculation is t equals x bar minus mu over s divided by the square root of n. Filling this in, x bar is our sample mean, here 6.8. Mu is the null hypothesized value, or the value from our null hypothesis, which is 7.25 hours. S is our standard deviation of 1.25 hours. And our n is our sample size, which is 123. Typing this into your calculator, you'd get that our t-statistic is negative 3.99. Now we have to determine what that value tells us about our population. To determine what our t-statistic tells us about our population, we will use the t-distribution table. First, we have to determine what type of test we are doing. This depends on what our alternate hypothesis was. Since our alternate hypothesis is that mu is different from 7.25, this means we are doing a two-tailed test. This is because we are expecting a value that is different from what we had. Since we are doing a two-tailed test, this means we'll look at the bottom row of our chart and match that with our appropriate alpha value. I'm going to run this test at an alpha value of 0.05. The next thing we need to know is degrees of freedom. The degrees of freedom for a one-sample t-test is equal to n minus 1. In this case, our n is 123, so our degrees of freedom are 122. 122 degrees of freedom are not on our table, so the closest value we can get is 100. Looking at the table, we will match that 100 with our 0.05 alpha and get a t-critical of plus minus 1.984. The t-critical is both positive and negative because we are doing that two-tailed test. You can see here that on the table it indicates that the t-statistic marks off a critical region on both the left and right tails. Drawing this out for our test, we can see that our critical region falls to the left of negative 1.984 and to the right of positive 1.984. We also call this our rejection region. Our t-statistic of negative 3.99 falls inside of this rejection region, so we conclude that we will reject the null hypothesis, meaning that we do have evidence in support of the alternate hypothesis. So yes, college students are getting a different amount of sleep compared to the average adult.